Hey guys, still working on pendulums, and I want to be able to show you uh, how we derive this formula to find certain things. Um, First, it talks a lot about what's the gravity uh, in a certain atmosphere um, when there's a certain time period and given a certain length. And so I'm gonna I'm gonna solve this for G, just so you get a picture of how we made this happen. And of course, I can't do anything with this until I get rid of the 2 pi. So we'll go ahead and divide both sides by 2 pi. And that goes away. 2 pi here. And so I'm going to erase. I know you know that you would be doing this a little bit differently. And so now I'm done with that, and I'm left with my square root of the length of the pendulum divided by the gravity in that certain situation uh, is equal to the time period over 2 pi. And I'm going to solve for G, but I can't because right now I have a square root. So I'm going to square everything, and that'll just make both of those squared and take away the square root symbol if I square both sides. Right? So I'm almost home, and really all I have to do for right now is divide both sides by L. So divide by an L and divide by an L. And I'm going to move the equal sign over so I have a little bit more room, and that cancels that out, right? That makes it a 1. So what we end up with right now is 1 over G is equal to t squared, the time period squared, times 2 pi squared over 2 pi squared times L. And we're almost home, and we can really look and see that 1 over G is just the inverse of gravity, right? So G to the negative 1 is the same thing as 1 over G, right? And so if this is the inverse, then to have G, all I have to do is flip this whole thing over. And I'll see that G is equal to 2 pi squared times the length divided by the time period squared. And if you look closely at the example problem that I gave at the very end of your reading yesterday, you'll see that inside that example problem, this is what they came up with. And I didn't want you to just think, oh, well, it's just one more magic formula that comes from nowhere. It's just their way of being able to jump right to it because they were able to derive that formula from it. So this is how we get to find gravity. If we want to find the length, we do a whole other set of business, and we don't have to flip anything, right? We know that the time period, and I'm going to leave myself lots of room here, equals 2 pi times the square root of L over G, right? And get this over here, so we divide by 2 pi by dividing, and I've already shown that, so we're good. We square both of these quantities, and we get rid of the square root symbol. And the best thing about this is if I just multiply both sides by G, I have my L. I don't have to invert at all. So t squared times G divided by 2 pi squared gives us L. And that's how that formula comes about if by chance you happen to be looking for the length of the pendulum. Okay, so there are ways to derive that one formula, derive 2 new formulas out of it. Right, so now if later on there are some examples that you need to, or problems you need to find the length, or you need to find the gravity and you've been given the time period. One or the other. There you are.